Hello everyone. Today we're looking at our fourth day in the series of congruents and taking a look at figures to determine if they are congruent or not, or if we do know that they are congruent figures, and can we identify those corresponding parts. So that's what we're looking at doing today. So in this first example, we are going to start off with knowing that these two figures are congruent because this is the congruent statement. The congruent statement names the figures, and there's the little congruent symbol in there. And remember, we learned from the previous day of notes that the order of the letters matters. So whatever is listed as the first letter will match up with the first letter in the second name. So we're looking at A being paired up with G. L is paired up with I, and X is paired up with W. So we can use that information to determine which sides are the corresponding and congruent parts. And we can also use that information to fill in the blank. So let me just demonstrate. We could even ignore the diagram for a moment, just pretend it's not really there, and we could answer this first question just by looking at the order of the letters. So here we want to say what part corresponds and is congruent to segment LX. Well, LX is the second and the third letter. So that would pair up with the second and third letter here, which is IW. So that would be segment IW. So you can answer many of these questions even without the diagram, just using the statement. But let's go ahead and mark up the diagram so we can keep track of what information we know. And I'm just going to start off with the name and finding those corresponding parts here. So let's start off with the angles. Angle A pairs up with angle G. So I'll just put a single arc in those two locations. The second letter is L and I. So angle L corresponds and is congruent with angle I. The third letter is X. So I'll give that a triple arc, and that would pair up with angle W. Now let's look at the sides. So if you look at the first two letters of triangle ALX, that would be the letters A and L. So that creates a side, segment AL. So segment AL is here, and the first two letters then pair up with the first two letters of GI, which is over here. So we're saying that the first two letters create segment AL, give that a single tick mark, and that would pair up with segment GI on the other triangle, and give that a single tick mark. So we can see these then are the corresponding and congruent sides. So like what we looked at earlier, the second and third letter is segment LX. Give that a double tick mark, and that would pair up with segment GI. Let's try that again. Segment LX is the second and third letter. That would pair up with the second and third letter here, which is IW, and IW on the other triangle is here. So give that a double tick mark. And then if you look at the first and third letter, that will create the third side of the triangle. So segment AX, which is here, pairs up with the first and third letter, which is segment GW here. So we'll give that a triple tick mark. And that way you can easily look at the diagram now and see what are your matching parts, and then transfer that information over. So, for example, we have 4 centimeters on the side with the double tick mark. That means on the other triangle where the double tick mark occurs, they have to be congruent, which means they are equal in length. So this is also 4 centimeters in length. Here, angle X is 92 degrees. That's with the triple arc, so that pairs up with angle W, which also has a triple arc, and that's then 92 degrees as well. You can see the 55 degrees here at G, that has the single arc. So in the other triangle, the single arc is A. That's also 55 degrees. So we can transfer information back and forth between the two diagrams, knowing those corresponding parts. And that makes it a little easier then to answer some of these questions, because we've already marked up the diagram. So part B says angle A is congruent with what? Angle A is congruent with angle G. You can look at the diagram, or you can look at the order of the letters. Now this question here, you have to watch out for. This is where some mistakes start to happen, and we see something similar also on part F, and we'll get to that in just a moment here. So take careful note of these two. Notice we have an equal sign. The previous questions were the congruent sign. So when you have the congruent sign, You are naming the part. But when you have an equal sign, we're not naming the part. This is asking the question, what is the length of this segment? How long is it from I to W? In other words, we need a number. Again, with a segment having a bar symbol, like segment LX, we're just giving it the name. Without the bar, that means we're not talking about the name of the object, but its value, its measure, its length. So from I to W, that is a length of 4 centimeters. So the answer is 4 centimeters. So notice the difference between when we have to name the segment versus when we have to give the number value, the length of the segment. Here in part D, we are just writing the congruent statement in a different form. They shuffled the letters around. So instead of triangle ALX, they now wrote it as triangle LAX. So they put L in front, and L pairs up with I. So I has to be in front. They put A as the second letter. A pairs up with G. So A and G are corresponding angles. And X pairs up with W. Now about the angles. Take a look at part E. This is angle I. So angle I is in the second letter's position, so that pairs up with L. So angle L. And so now when we get to part F, again, notice we have an equal sign, which means we're not naming the angle that pairs up with angle A, but we want the size of the angle. We know angle A is corresponding to angle G, and we saw that angle G is 55 degrees. We transfer that information to angle A here, and that's also 55 degrees. So again, notice the difference between when we name the angle versus when we give its measure. And then lastly, we want the measure of angle L. So the measure of angle L we don't have, but we do know that all three angles add up to 180 degrees. So we can take 180 degrees, we could subtract away the other two angles, the 92 and the 55, and that'll give us a result then of 33. So in this example, we started off with knowing the triangles were congruent, and that means we could identify the corresponding parts and either name them or find their values. Now we're going in the reverse order. We don't know if these figures are congruent. We hope to look at the markings in the diagram to figure out if they are congruent. So we will write a congruent statement for any figures that can be proved congruent. This is not a two-column proof. This means, do we have enough information in the diagrams to tell us, do we know for certain that they are congruent? And if the figures are congruent, then we can write a congruent statement. If they're not congruent, then we cannot write a congruent statement, because a congruent statement communicates that they must be congruent figures. And what we have to look at is we have to look at each pair of corresponding parts. So let's start off with figure A. Here we see a side with a single tick mark, and that is paired up with a side of a single tick mark. So we know these are congruent and corresponding. We see a double tick mark and a double tick mark, so there's a second pair of sides. There's a third pair of sides with a triple tick mark, and a fourth pair of sides with a quadruple tick mark. So each pair of corresponding sides is congruent. But now you also have to check the angles. We see angles with a single arc, a double arc, a triple arc, and a quadruple arc. So every pair of corresponding angles is congruent. And because we checked every single pair of corresponding parts, then we know that the figures as a whole will be congruent to each other. So we don't just say yes or no. We're going to write a congruent statement to say that yes, they are congruent. So pick a letter and work your way either clockwise or counterclockwise around that figure. So this is figure CDEF. CDEF is congruent with, again, the order of the letters matters. So C has the single arc, so that would pair up with the single arc here at H. D is the second letter that has the double arc, so that would pair up with the double arc here with I. So it looks like we're going H, I, J, K. That is answering the question by saying, yes, these are congruent figures, and we wrote that congruent statement. Now let's explain your reasoning, meaning what did we really do to determine that they are congruent? we looked at each pair of parts. So we will say each pair of corresponding parts is congruent. Each pair of corresponding parts is congruent. What that means is each pair of corresponding sides were congruent and each pair of corresponding angles are congruent. Now I want to focus on this word here when we say each pair, and let me show you a common mistake that some of my students make when they're taking the quiz. When having to explain this, oftentimes I get a statement like this instead, and I wrote it out ahead of time so you can compare these two, where instead of saying each pair of corresponding parts, they say all pairs. Notice the difference here. If we were to say all pairs of corresponding parts, here I'm focusing on sides, but we could say all pairs of corresponding parts are congruent, well then that would suggest we have something like a square, where all the sides are congruent. And that's not what we see here. We don't see all of the sides congruent. We see each pair is congruent to itself, but the first pair is not the same size as the second pair, and the second pair is not the same size as the third pair of sides. So be careful whether you say each pair versus all pairs. To say all pairs is wrong unless you know you have a square. So instead you want to say each pair of corresponding parts is congruent. Alright, take a look at figure B. I see this first pair of sides with the tick marks, so they are corresponding and congruent. I see the second pair of sides with a double tick mark. They are corresponding and congruent. So obviously there's only one side remaining on each triangle, so these are definitely corresponding. But are they congruent? There's no tick marks there. So we don't have enough information to show that the figures are congruent. We cannot write a congruent statement. Same with the angles. We do have one pair of angles that are marked. Angle R and angle X are congruent and corresponding. But the other angles, even though we could figure out that these would be corresponding, are they congruent? No, they're not. We don't have any information telling us they're congruent. So I cannot write a congruent statement and explain my reasoning. Why is that? Well, in short, we don't have enough information, but let's be a little more specific than that. I could say something like, let's focus on the sides here. Segment TV is corresponding but not congruent with segment YZ. So remember, we have to have corresponding parts that must also be congruent for us to say the figures as a whole are congruent to each other. So that's what we're going to be looking for in these diagrams. Here are a couple more variations on this. Here we have two triangles, and you can see they are sort of overlapping here on this long side. And we want to know if we have enough information to determine the triangles are congruent. Alright, so let's take a look at the sides. Again, we have a pair of sides with a single tick mark, so they're corresponding and congruent. We have a double tick mark, so again, a pair of sides that are corresponding and congruent. The third side of the triangle then is here in the middle, and there's no marking here. We know it's the third side of the triangle, so they do correspond to each other, but what do you think? Is it congruent? And the answer is yes. Here we are allowed to put the tick mark in because the two triangles share a common side. Notice that on this top triangle, you have on this top triangle a segment that goes from N to L. And on this bottom triangle, you have a segment that goes from N to L. What we're saying is that the segment that is on the top triangle is exactly the same as the segment on the bottom triangle. Well, how do we know that? Because they have the exact same endpoints. That means they are congruent to each other. And it's been a while since we've learned about this, but this is the reflexive property of congruency. All right. It looks like it's just the same letters, but if you color code them differently, you can see that this segment NL came from one figure and this segment NL came from the other figure. Because they have the same endpoints, they are the same size. That means they are congruent. So here we are allowed to add the markings in. Now a quick check of the angles. You see an angle with a single arc. Here's an angle with a double arc. Here's a pair of angles with a triple arc. So all of the corresponding parts are congruent. So we can say, yes, triangle NLK is congruent with triangle LNM. Same reason as above, each pair of corresponding parts is congruent. I also get the question sometimes just on the grammar of writing a statement like this. Sometimes I have students who ask me, shouldn't it be each pair of corresponding parts are congruent? Thinking that this S, as like multiple parts, we have plural parts, shouldn't we say parts are congruent? And the answer is no, because parts is not the subject. The subject is each pair, and that's singular. Think of your pair of jeans. Even though jeans has the S on the end of jeans, when you say a pair of jeans, you only mean one of them. So each pair is the subject. There's your verb, and that's why it's singular. So singular subject paired up with a singular verb, that's why it's each pair is congruent, and it's not each pair are congruent. Okay, here's the last diagram in this series. Again, we're looking to see if we have corresponding and congruent parts. And so we have a pair of sides with a single tick mark, double tick mark, triple tick mark. That looks good so far. Let's check the angles. We have single arcs, double arcs. We don't have any markings here on the third angle, so the question is, are they congruent? And the answer is yes. Do you remember why? What's the name of that angle pair? So I can't call this angle E because we have lots of angles at vertex E. This is angle DEG. So angle DEG is congruent with angle HEF because we learned that vertical angles are congruent. And so that's why we're allowed to add those markings in. So notice that with some diagrams, we're not allowed to add any more markings because they don't share a common side, like we saw here in part C, and they don't have vertical angles, like we see here in D. So be careful. You can't just start adding markings whenever you feel like it. Only if we share a side, the reflexive property, or only if we have these opposite angles, vertical angles, can we mark up these particular kinds of patterns. Now we have every pair of corresponding part congruent, and so we can say triangle DGE is congruent with triangle HFE. Why? Well, the exact same reason as before. Each pair of corresponding parts is congruent. Alright, let's take a look at the next page. We have now a variety of problems on the back side here where we're looking at figures that are congruent, and they're asking us to solve for a particular size of an angle or side length or finding a particular variable value. And it all comes down to identifying what those corresponding parts are. So let's look at example 3. In the diagram shown, figure FGHJ is congruent with figure STUV. Let's find the value of x and then find the measure of angle G. If you look at the figures, you can see that figure FGHJ has a right angle, and at G it has an angle represented by this expression, 2x minus 7. And if you look at the other four-sided figure, you see all four angles are identified. So we have more information than what we really need here. Some of these are going to be extraneous information, or just decoys, if you will. So that's why we want to go back to the statement and remember how to pair up those corresponding parts. If I want to find the value of x as the variable, what is the variable x? I see x is only found here at angle G. So I want to take a look at the letter G in the congruent statement and say, G is the second letter in that statement. That will pair up with angle T. So that means angle G is congruent with angle T. So that tells me which two to use. So we're using angle G and T, and we can ignore angle V, we can ignore angle S. So angle G is the 2x minus 7, and angle T is the 103 degrees, and that's how we set up our equation to then solve for the variable. Alright, so let's move the constant terms to the other side, to the right-hand side. So we get 2x on the left and 110 on the right, and then divide away the 2 so that we can isolate the variable, and there it is. X is 55. Again, it's not 55 degrees, because x is not the name of the angle. We found the value of x. Find the measure of angle G. Well, we know G is congruent with T, and angle G should be the same size as angle T. So we can say the measure of angle G is 103 degrees. And there are those two answers. So you can see we're relying on the congruent statement to find the pair of corresponding parts. We'll continue doing that here in this next example. Here in example 4, we know that triangle ABC is congruent to triangle DEF. We're trying to find the value of each variable. And this is pretty straightforward, as we only have one variable here, the y. So we're going to try and solve for y. Alright, where is that? Well, y is located at angle E. Angle E, I'm looking at the congruent statement, E is the second letter, so that would pair up with angle B. Alright, where is angle B? There it is. I don't have a number there. We would normally say that these are, like, if I had a number, I could just say, oh, y equals that many degrees. But this is missing. So what we're going to do is we're going to transfer the information. If angle E is y degrees, then angle B is also y degrees. So in other words, get a triangle where you have all the angles identified with something, then we can say all three angles have to add up to 180 degrees. So this is a 90-degree angle, and this is a 65-degree angle. This is my y degree angle, and they all add up to 180 degrees. So we'll solve for y that way. So we'll isolate the variable, we'll subtract away the 90 from both sides, we'll subtract away the 65, and we end up with 25. Again, no degree symbol here because it's just the variable. So that means this is 25, and this is also 25. Alright, again here in part B, looks like we only have the variable y. So same idea, we want to find those corresponding parts. So the variable I'm trying to solve for is located at angle M. M is the second letter in this triangle's name, so that will pair up with angle T. Alright, so here's angle T, and once again I don't have a number there to just say, hey, y is this much. So just transfer that information over. Alright, well, I would like to add up all three angles to 180 degrees, but I'm missing this information. So we're going to transfer that 65 degrees from the left triangle to the right triangle as well. The double arc tells us those are congruent parts. So 65 is also here. So again, the strategy for these two problems is get a triangle with all three angles with information, and then you can add them up to 180. We could have also transferred the 45 degrees from angle R to angle K. So it doesn't really matter which triangle you end up working with, just get a triangle with all the angles, and then we can add up those triangles angles to our 180 degrees. Alright, so we'll subtract away the 65, we'll subtract away the 45, and we get 70. Here in part C, again we have the name listed up top. We see that triangle XWY is congruent with triangle PQY, But this time the triangles are not neatly aligned. You can see that they're kind of rotated, where this triangle on the left has its longer side here on the bottom, and on the right hand triangle its longer side is here running vertically, and there's a little bit of an overlap. So let's see, we're trying to find the value of the variables, and we have an x and we have a y. And I see that the x variable is located here at angle P, and there's a single arc, and I see that the left triangle is already marked up with a single arc. So right away we know that x and P are corresponding parts. They are in the first letter of the names of the triangles. But here with the symbols we see the single arc. So that means if this is 56 degrees, angle P is also 56 degrees, right? So transfer that information, and now we can set them equal to each other. So to find x, we can take this 3x minus 7 and set it equal to 56 degrees, because those two angles are going to be congruent. They'll be the same size. Alright, let's move the 7 to the right hand side. I get 3x equals 63, and then we'll divide away the 3 to get x by itself, and I get 21 as a result. Now let's think about trying to find y. So here is the variable y up here in angle Q. So again, notice that in some of these cases, if the diagram is so small that we can't actually fit the number information inside, we draw these little arrows. And so even though this 2y is parked outside the triangle, this little arrow is trying to point us here to say, hey, it belongs to this angle Q. We saw the same thing down here at angle P. There was this arrow pointing us inwards like that. So y is up here at angle Q. Q is the second letter that would pair up with W, and I don't have any information there. So I'm going to transfer that information because both of those angles are the same size. And now if we take a look at this triangle on the left, we have something in all three angles locations, and we can add that up to 180 degrees. So now let's find the variable y. So we have an angle of 2y degrees, we have an angle of 56 degrees, we have an angle of 90 degrees, and add all of that up to 180. And now let's work to solve for the variable. Alright, so let's see, I'm going to subtract 90 from both sides, we're going to subtract 56 from both sides. Right, that's how we'll get the term of 2y by itself. And I believe that's 34, then we'll divide away the 2 to isolate the variable, and we get 17 as a result. And for our last problem here, this is the most complex algebraically because, as you can see from the hint, we're going to solve this using a system of equations, and I'll talk you through that here in just a moment as we get this set up. So we do know that these triangles are congruent, and I see right here from the markings on the diagram I have a single arc at angle R, a single arc at angle V, so we know these two angles are the same size. So I'm going to go ahead and set that up. I'll just create a little bit of a marker here. Alright, so we know that the 2x plus y equals 120. The problem is I can't solve for x or y because I have too many variables in this one equation. If it was just x or just y, it would be no problem, but I've got too many variables, so I can't make any progress with this just yet. I also see that with the double arc, like this, these two angles are the same size, so I could transfer this information down below. I also see the 20 degrees, there's a triple arc there, that pairs up with this triple arc. I'm going to transfer this 20 degrees up and use the top triangle, because now you can see that we have a triangle with information in all three angles, and we're going to add this up to 180. So I'm creating a second equation because I can't solve my first one. And so we have an angle that is the x minus y. Add that with the 120. Add that with the 20, and that adds up to 180 degrees. Let's move the constant terms all to the right-hand side. So right now I still have the x minus y where it is on the left-hand side. And I'm subtracting away the 120. I'm subtracting away the 20, which means I'm really subtracting 140 from both sides. So moving all of my constant terms to the right, I just have 40 on the right. So again, I'm kind of stuck. I have another equation with too many variables. I can't solve for x or y. So when you have two equations with two variables, we're going to use the system of equation to solve. And we do that by taking one of those equations and plugging it into the other. Let's take a closer look at how we might do that. Alright, so I'm going to take this equation on the right with the x minus y because we can easily get a variable by itself. We could have picked this first equation and picked y to get y by itself, but whatever equation you were working with, you want to find one where you can easily get one variable by itself. In other words, I'm going to move the y to the other side, so it looks like x equals 40 plus y. And we're going to now take this, because we have something that represents x, and we're going to plug it in for x in the other equation. So that's our system of equations. We'll take one equation, get a variable by itself, and then plug it into the other equation. So here we have 2 times the value of x. Well, what we're saying is that we have 2 times the value of x, and x is represented as a 40 plus y. So that's where the substitution just occurred. And then we have a plus y equals 120. Plus y equals 120. So that's where the substitution just occurred. So let's use our distributive property and multiply 2. So 2 times 40 gives us 80. 2 times y is 2y. And then we have a plus y and an equals 120. So that means I now have 3y. And I'm going to subtract 80 from both sides, and that will give me 3y equals 40. And then when I divide by 3, I do get a decimal answer here. We get 40 divided by 3, which will be rather awkward to work with to get the final result. So I'll go ahead and change that into a decimal value. I'll use my calculator, and I'll go to 2 decimal places. So 13.33 is my value of y. Most of our problems will have numbers that come out as nice integers, but occasionally we will hit a decimal, and that's okay, nothing wrong with that. Now we're not quite done because we did find a number answer for y, but we haven't found one for x. So this is the final step. We now have to take the value of y and plug it back into the first equation that we were working with here, what I have on the right hand side. So x is going to be found by substituting in place of y that 13.33. So that's where the substitution occurs, and we get a final answer for x of 53.33. And that's our notes for today.